Welcome. We'd like to consider an example of solving a quadratic equation that really we'd like to still use the zero product property with. However, it's not quite as easy to factor as other examples. So let's work towards solving this quadratic by first observing it in that nice form of ax squared plus bx plus c is equal to 0, right? Observe the quadratic equation. Let's start there. I'm going to distribute the 2x inside of the parentheses to get 2x squared minus 4x is equal to x plus 3. I can subtract the x and subtract the 3 from both sides to get 2x squared minus 5x minus 3 is equal to 0. When we have a leading coefficient, when our a value is 1, that's very convenient. It becomes an easy quadratic to factor, assuming it's factorable. When we have that leading coefficient that is not 1, well, we have to start taking other approaches. Now, some people use what quite simply is the guess and check method. I think a lot of people will write some x's like this and write some numbers and multiply, and that approach can work, but it's really kind of an informal or a disorganized guess and check method. And what I would like to present to you today is called the AC method. It's really a similar approach to what people do here. Now, if you're not familiar with this, I apologize. I'm not actually familiar with it either. I've just seen students submit it. When it comes to the AC method, we're going to formalize or organize this sort of thought process. So if you're not familiar, here we have an organization that will help us out. So when we refer to the AC method, the numbers a and c, we are multiplying together. Those actually refer to the a and c of the quadratic equation. So our a value is 2, and our c value is -3. So a times c gives us -6. Now what I have is the ability to work in a similar way to having a leading coefficient of 1, right? I can ask myself what multiplies to something and adds to something else are the two questions. So the difference here is I want to multiply to a -6 and I want to add to a -5. Okay, so what is going to multiply to -6 and add to -5? Now I already know 2 times -3 multiplies to the -6, but 2 plus 3 gives us a -1. So it doesn't give us that desired -5. But I like to be methodical. So what multiplies to 6 here? So I'm going to have a -6. So I'm going to have a positive or a negative, well, a negative somewhere in here, -1 times 6. So I start with the simple things. 1 times 6 is equal to 6. Fantastic. And then the question is, can I create a -5 from one of these things being negative, right? I need a negative of 1 times 6. One of these has to be negative. -1 plus 6 gives me a +5, so that doesn't work. However, if I take 1 plus a -6, then I do get that -5. So what I would like here in particular is I would like 1 times a -6, and that's going to give me the -6 for the product. And I'm going to split this -5 as a +1 and a -6. So 1x minus 6x. And I still have my 2x squared. Again, the -5 became a +1 and a -6, and I still have my -3. At this point, I have to use what's called the grouping method. So if you're not familiar with the grouping method, feel free to pause and see if you can find some references to that. Those should be pretty available. But the grouping method has us group together the first 2 terms and the last 2 terms. When we do so, we'll do so explicitly a moment. 2x squared plus x. Let's see here. If I want to group these 2 things together, I got to be very careful here. I have to put those parentheses around very carefully. I'm going to put the parentheses around the negatives. I'm going to include the sign of both of those. So -6x minus 3. But I can't have nothing in between these parentheses. So I'm going to go ahead and add them because I can add a negative. And that's still subtraction. That's fine. All right, so I've grouped them together. Now what I want to do is I want to pull out the greatest common factor from each of these groupings. That's going to give me a greatest common factor of x in this first grouping. So I have a 2x plus 1. And I have a greatest common factor of -3 in this second grouping. So I pull out that factor of -3. So plus -3 times, so minus 3 times. 3 times a, the result is 2x plus 1. Hey, awesome. I like this. I like this because what's left over is the same thing. So now what I can observe it as is something, right? X times something minus 3 times that same something. So I have a common factor of that something. I can pull that common factor off. 2x plus 1 is a common factor between this term and this term. And after I pull off the 2x plus 1, I'm left with x minus 3. At this point, I have the product of two binomials is equal to 0, and I can use the zero product property to set each of those factors equal to 0. So 2x plus 1 is equal to 0, or x minus 3 is equal to 0. These resulting linear equations, of course, are pretty straightforward and easy to solve. Subtract 1 to get 2x is equal to -1. Divide by 2 to find x is equal to -1/2. Or add 3 to both sides to find that x is equal to 3. This gives us our two solutions to the quadratic equation.